Today we'll be doing 4.2, differentiability with piecewise functions. Okay, so we'll be doing these algebraically. Let's go forward. Okay, first thing to remember, for differentiability, it needs to be continuous first. So first you need to check these three rules, yes? You can do the first two in any order you want, but you need to check these three rules. And then after you've checked the three rules, you can check if the slope from the left is equal to the slope from the right. That's only afterwards, after you've checked these. So basically, we're going to be doing what I taught you guys how to do in chapter 2, but with an additional step at the end if the function does happen to be continuous. Okay, tell whether the functions are differentiable at the changing points. If it is not, give the reason why. Okay, so I'm going to check if these things are differentiable. Remember, we got to start out with the first rule, and the first rule is, does it have a limit as x approaches -1 for the function f of x? And here I should have probably just called it y because the function is y, but I put an f of x. Okay, so remember, first thing you need to do is, do I plug into both the functions? Do I only plug into one of them to check the limit? In this case, we need to plug into both of them because the less than checks the left side, the greater than checks the right side. Okay, so let's plug in for the left. Let's plug in -1. So -3, -1 squared plus -1 plus 2. Okay, well that'll give us a 1. So -3 minus 1 plus 2 would be -4 plus 2, -2. Okay, so from the left-hand side, we're approaching a y value of -2. Let's check the right-hand side. So 2 times, we plug in our x value, -1, will give us -2. And then, so from the right-hand side, we are approaching -2. So from the left and the right, we're approaching the same value. So we do have a limit, and the limit is -2. So rule 1 checks off. We do have a limit. Let's check rule 2, that there is a point, so f of, and remember, we're checking it at that x value, -1. So let's plug it in. We use the top function because that's where it is equal to, and we already did that. I did that right here, so I'm not going to redo it. The answer is -2. Okay, it does have a point. Okay, now let's check rule 3. Does the limit equal the point? And yes, and I need to properly write this out, okay? This is where you guys have problems. The limit as x approaches -1 of our function, f of x, is equal to our point. Okay? Step 3 is good. So the function is continuous. I can properly say that it is continuous, and I should say where I checked it at, x equals -1. I know it is continuous at x equals -1. Okay, now I need to check that last rule to check if it's differentiable. Remember what the fourth rule is. Here, it's the first rule of differentiability, but the fourth rule in this whole thing, that the slope from the left-hand side, okay, so let's write it out here, the slope, so the derivative from the left-hand side, remember that means the limit as x approaches -1 from the left is equal to, from the right-hand side, it has the same slope. Okay, so what we're going to need to do is we're going to need to take the derivative of the left-hand side and the derivative of the right-hand side and see what we get. So here, let's call this L prime, left-hand side derivative. Taking the derivative of this, we got -6x plus 1. Okay, that's an equation to find the slope anywhere we want. And remember, we want the slope at -1. So we're going to have -6 times -1 plus 1. That's going to make 6 plus 1, so 7. So from the left-hand side, we have a slope of 7. That's a large positive slope. It's going straight up from the left-hand side. Okay, let's check the what happened here. Okay, let's check the. It keeps on happening to me. Give me a second, guys. Okay, I'm gonna have to write up here or something. Sorry. Okay, here, I'll do it over here. So we'll call this the r prime, okay? The derivative from the right-hand side. Well, the derivative is just gonna be 2. And we don't have anything to plug the -1 into, so our slope from the right-hand side is 2. Our slope from the left-hand side is 7. Therefore, it's gonna make a sharp turn. So, at this point, you would say, not differentiable. Oh, now it lets me write down here. Not differentiable at x equals -1. And you got to write out your reasons. The limit for the slope as we approach from the left-hand side of -1 does not equal the limit as we approach -1 from the right-hand side for the slope. Okay, that's our answer, and there's our reasoning behind it. Yeah, you need to write it out mathematically. I will count it wrong if you don't write it out like this. Okay, so let's do this one over here. Okay, remember we got to check if it's continuous first. So first rule, check if there is a limit as x approaches, and we are checking it at 2 in this case, and we have a function f of x. Okay. I need to plug into both of these. This one tells me that it's from the left, and this one tells me it's from the right. Remember, you don't always plug into both. Remember, there are the does not equals and the equals ones. And does not equals is how you check limits, and the does equals is how you check points. Okay, now neither one of these were those, but this one was one of those ones where you got to plug into both. Okay, so let's check from the left. So we're going to have 3, 2 squared minus 5 times 2 minus 1. Okay, that's going to give us 4 times 3 is 12 minus 10 minus 1, which is going to be 1. So from the left-hand side, we are approaching the value 1. Let's check it from the right-hand side. Plug 2 into there, so 7 times 2 minus 13. That's going to be 14 minus 13. That's 1 as well. Okay, we do have a limit. The limit is 1. Okay, so check mark on the first rule. Okay, let's see if it's got a point. F of 2 equals. Okay, well, here's the equal sign. So we plug into this function, which we already did. We did that right here, right? And it was 1. Okay, sweet. Check mark on that. It does have a point. Okay, third rule. The limit as x approaches, we're checking at 2 of our function f of x. Okay, are they equal? Yeah, they are. So I'm going to put equals f of 2. We're good to go. It is continuous at x equals 2. Now we got to check if it's differentiable. So fourth rule. Write it out to yourselves, okay guys? This is important. The limit as x approaches 2 from the left, we're talking about the slopes, so f prime of x. It needs to equal the limit as x approaches 2 from the right. We're talking about the slopes. Okay, so let's take the derivative of the left. I'll call it L prime again. Okay, the derivative from the left would be 6x minus 5. Okay, we plug in 2. So 6 times 2 minus 5. That would be 12 minus 5, which gives us 7. Well, we got a slope of 7 from the left-hand side again, just like the one over there. Okay, so we got a slope of 7 from the left. Let's check r prime. Okay, the derivative of that function would just be 7. And then we don't have to plug in 2 because, I mean, the slope's always 7 on that one. So, from the left and the right, they do have the same slope. So, we're good on the fourth rule. So, it is differentiable at x equals 2. So it's continuous and differentiable at x equals 2. Okay, let's go to the next slide here. Tell whether the functions are differentiable at the changing point. If not, give the reason. Now notice, on this one, I only included this for one reason because I put a does not equals and an equals sign here. Okay, remember, you still got to do all the same stuff. Do the rule 1. Limit as x approaches 2 of our function g of x. Okay, which one or both do I plug into to get the limit? Well, remember, the does not equal sign is for limits. So I'm going to plug into this one. So let's see what it is. 2 squared minus 4 all over 2 minus 2, which is going to be 0 over 0. Okay, remember, that's not where you stop, though. Check your limit. If you're checking your limit, you can then factor and cancel, right? So let's do that. We can do x plus 2, x minus 2, all over x minus 2. They cancel. We had a hole. This is our new function. Get rid of this old one. It's ugly. It has holes. We don't like holes. Here's our new guy, x plus 2. Okay, we can plug 2 into there. So our limit is 2 plus 2, which is 4. So remember, we only had to plug into the bottom one to check the limit on this one. So check, we do have a limit. Second rule, do we have a point at 2? Well, let's see. We're going to be using this one up here for equals 2. That's for points. 4 times 2. That's going to be 8. Okay, so check. We do have a point. Third rule. Are these two things equal, the limit and the point? No, they aren't. Okay, it failed this rule, so it's not continuous at x equals 2. Now, you got to write it out correctly. Why is it not continuous? The limit as x approaches 2 of our function g of x does not equal g of 2. I just realized I did this as f of 2. It should have been g of 2. Does not equal g of 2. The limit doesn't equal the point. Not continuous. Therefore, not differentiable at x equals 2 either. Yeah? Because if it's not continuous, it's not differentiable. There we go. That's everything.